Okay. Close this down. Okay, so when you have your RStudio open, it should look something like this. If it's not this cool, because it's like the very nerdy dark background and white or bright characters, then you can just change it in File and Preferences. Now RStudio and Preferences for Mac. For Windows, there should be Preferences as well. And in the Preferences or Options panel, there is a Appearance where you can change from the different themes, and you can change it to dark background. Okay, so before we start doing the programming, so what do we have here is, first of all, in the upper left corner, we have a window for an R script. So if you write anything here, it will remain here, and you can save it as a standalone script, or you can run it in whole, or you can run it line by line. We will go through this today. If you don't have this here, so if you have something like this, then you can just put your R script window by saying create new R script. It will be there. In the bottom left corner, we have the console or terminal. I don't know if there's any difference. Oh yeah, this is just Mac terminal. We don't use the Mac terminal itself. We are just using the R console. So this is where you can do one-line comments. So if you just curious how much is 5 plus 4, you just write in 5 plus 4. It gives you the result. So you can, of course, do way much more calculations and more sophisticated calculations here as well. So we will work sometimes here, but I think it's much better to work in your R script, because you can then save it, and it's actually a very good way to document what you are doing, a very good way to save your comments for the future. In the upper right corner, we have the environment, which is now empty, but as soon as we will start defining variables, they will be here. You also have the history here, which if you just installed your RStudio, then it's empty. Mine is, of course, is full of comments because I'm using R a lot. And you can have 5 connections here if you have 5 connections, but we don't have any. From the bottom right corner, the 3 most important tabs are the plots. So we will have the plots here. Later, the packages, if you have to install or if you have to load in any packages. We won't touch packages, I think, today, but from Tuesday we will go to the functions, and we will probably go and meet with a few packages, and especially after a few meetings we will go and see the ggplot, which is one of the most important package of R. And also very important tab is help. So any comments or any functions you want to use, you can have a very detailed help on that comment here. Okay, so as I said, we will work mostly in the upper left corner, and the most important thing you can do here now is that you can write in your comments, and they will be invisible for the R script. So you can write any lines, just start simply with a hashtag, not this one, not this one. It's the option 3 on a Mac keyboard. And anything you write here is a comment, so it won't be executed by the R compiler. So the first thing what every programming language do is just print out hello world. So how we can print out something, and it's actually very easy because just have to say print and if you want to run this, you can run here the whole script. You can, this is just the current line. Or you can just go on the line, or you can go on multiple lines and hit Command Enter on Mac, or you can hit, I think it's Control Enter probably on the Windows, but please try it, and if it's not, please correct me. Of course, we don't really want to do as simple things as this one, but before we go into what we can do with VR, I would like to share a few of my principles in programming. First of all, that's not principle, that's an excuse. I'm programming mostly in Perl and sometimes in R. So if I will stop and think, that means that I'm Googling and try to find a solution for those things which I would know in Perl much better, but not in R. But I'm trying to catch up all those informations which I have to give to you. But that, forgive me if I have to stop sometimes. The second thing, programming is not that crazy and mystical thing, what I think many people think. You have to do in programming what you would do by your hand. The same kind of things. You just have to learn that if you do something manually, what's the command, what's the structure, what's the syntax in your programming language, which does the same, but you don't have to change your thinking. Let me give you a very simple example. If you have an Excel table with numbers, let's say it's 8 columns, 8 rows, so 64 numbers, and you have to find the smallest number in that table. And probably you will start with the A1, then A2, or A1, B1, C1. So you will start in the beginning of the first row, and you will go through the 8 columns, and then go to the second row and go. And if it's printed and you have a highlighter, then you can just simply highlight the number which is the smallest. And if you find a smaller number than that one, you can just highlight that. And when you finish with the table, the one which is the last one that was highlighted will be your smallest number in the table. So the programming does the same. If you want to find the minimum number, the smallest number in a table, which is sometimes called matrix, in R it is called matrix, for example, then you have to go through all the lines and all the columns, and instead of using a highlighter, you will use a variable where you will put the number if it's smaller than the minimum that was there before. Of course, you have to start with a number. If you don't want to start with a very high number, that's sometimes you can do that. You can, okay, let's set the minimum value for 100 million, and probably I will find something which is smaller than that. But sometimes you will have huge numbers in your Excel table, so you can just choose, for example, the very first row and very first column cell and use that as your initial minimum, initial smallest number, and then go through all the columns, all the rows, the same way as you would do manually. So I think it's very important that you don't have to think differently just because you are doing programming. You have to think with your researcher brain, which is perfectly capable of doing programming and think smartly. And you just have to learn how to do these things in programming. And the good thing is that there are so many people who try to understand this, and so many people who asked already what you will ask. So in many cases, if you have a problem, you just Google your problem, how to find the smallest number in a table with R or with Python or anything else. And there will be the answer, the first or second link, which is usually a a stack exchange or something like that, it will be there, and you will understand how the programming does this. So let's start with variables, one of the main components of programming. First of all, why do you need variables in a program? The thing is that as soon as you calculate something, as soon as you read in something from a file, you have to put it somewhere. Otherwise, it will just disappear from the program. So if you say here 5 plus 6 and then execute, then you will see down on the bottom left corner, then we have the result, which is 11, but it's not there anymore. Of course, again, you won't do simple calculations like this, but if you do a bit more complicated calculations and you have to do it twice, as soon as you have to do the same thing twice, or if you need the result later in your program, then you have to put that into a variable. It's actually, you just have to think about it as a small piece of memory, not in your mind, but in the programming environment mind. If you run your program as a standalone script, what we will do later, not now, in RStudio, if you put anything into a variable, it will remain there. But if you run something as a standalone script, then all these variables, of course, will be purged from the memory as soon as the script finishes running. So let's put this very simple result into a variable. What you have to do is just simply give a name. So programming is usually very creative because you have to give a lot of names for your variables. Let's just give the result name. And in R, that's the most common way how you can assign a value to a variable. So as soon as you do this, it will appear here in your environments now, and you see that you have a variable which is called result and which is a numeric type variable because it's a number. What if you want to put not a number, but as for example, something like a text or a character? Let's create another variable. Now, we tried not to use variable names that has some kind of connections to our comments. So that's why I deleted the text. As you can see, if I'm starting writing text, then actually the text itself is a command in R. So I will try to avoid to use a variable name text. One easy solution is just to simply say text like this, because as all programming languages, R is also case sensitive. So as soon as you have a text with capital T, it's different from the text with small caps. If you want to put in a text or a string, then you have to put it into parentheses. So let's say hello. And if you run this again, Command Enter or Control Enter, then you will have your text, your variable called text, which has a value of hello. And if you just go over here the text, you will see that the type is character. In default, okay, just the same things for naming the variables. I think I also told this in the command line, that never use spaces. So it's not good to say that my minimal value is 100. That's not good. You can use underline. It's okay. But in programming languages, we don't really like using underlines. There is one thing which is much more common, is that if you want to give a long name for a variable, a descriptive name, which is made of more than one word, then each word should start with a capital. So saying like minimal value, but you can also say like minimal value here, that you are starting with capital M and V. So this will make the reading easier as well. And also it is absolutely programming safe. As far as I remember, you shouldn't start a variable name with a number, but I think this is again depending on what kind of programming language you use. But usually it's better not to start a variable name with number. And also, I think here, because now we almost covered all the simple variable types in R, there is one more. So we actually have 3 main types. We can store, and this is just the simple one container variable. So a variable which contains one thing. It can be a whole book if it's one string of millions or hundreds of thousands of words, but it will be one thing within the variable only. So we have the type which contains characters or strings, like the text variable here. The type is, as you see, is character. We have the type which contains numbers, like the result, and its type is numeric. And we have the last one, which can be true or false. So let's give it a name. The reason why I'm calling it a Boolean variable, because it's actually a Boolean type. Or in R, it is called a logical type. A logical type variable can be only true or false. That's the other one, false. I will open the chat. Yeah. So the question is the string just not a name for a character? And this is again different in different programming languages, and I think it's very important here that I will try to teach you much more on not only just how to program in R, but how to think when you are doing programming. So try not stick with all the nomenclature of R. In many programming languages, there are different types for strings and characters. So the character type is usually just one letter, while the string type can be words, sentences, or a whole book. In R, everything that is not numeric or not logical is has a type of character. So it's actually a different name, but it's better to call them string. We can also assign a very simple value here. We don't have to assign something. Rian, did you push the command enter or just the enter?
Maybe it's just because I'm just doing enter.
Yeah, so the enter will give you a new line. The command enter will give you a new line and execute that line as well.
Okay.
And you can always go back and if you again say command enter, it will be executed again. Is it working now?
Yeah, it's coming up in the console, but not in the global environment, not to the right.
Do you have it, this one opened? Do you have anything there?
Global environment's open. Everything's open the same as yours, but it's
Do
now.
Do you have anything in your environment?
No.
Other things?
Ah, no, it's starting to come up now. It's okay.
Okay.
It's fine. Sorry. Sorry. Carry on.
Okay.
Apologies, everyone.
Okay. The other thing, and I hope it will work for me. Now, I'm not sure that R is that strangely. I mean, okay. So if you store a number in R, let's say it's 3, which is actually an integer, but R in default, I think, stores numbers in decimal format. So even if it's an integer, it's for the R, it's actually 3.0000, and depending on if it's single precision or double precision, the number of decimals depending on that. If you store a lot of numbers and you know that you are storing integers, it's better to store them as integer. And I think it is possible, but I'm not sure. In many programming languages, again, it's the same as the difference between string and characters in different programming languages. Storing a number as an integer eats up way much less memory. So if you are working with a lot of numbers and you know that you are working with integers, then it's better to store them as an integer. I think there is an integer command. Yes. No, this is not that what I wanted. Okay, so I'm not just trying it here. So if I say as integer, as dot integer, that's a command which will convert this number to 3. So the question is, if I'm saying that the result is 3 here, then it is stored as a numeric variable, and it's 56 bytes. And if I'm saying that result 2, it's perfectly okay to put numbers in variable names if it's not the very first character. Result 2 is as integer 3. Let's see if it will be different. The size seems the same, but we have an L there, which is not really there. It's just, I think it's just say that it's an integer. Because if we here in a console say result 2, then we get back the value, which is 3. As soon as you have things in your variables, you can just keep it this. You can work with those as well. So let's just try here and add result to result 2, result and result 2 together. Both of them are 3. So if I say result plus result 2, it will be 6. So it is in your memory, and you can use them as many times as you want. Of course, you cannot add up things that are not the same type. So let's try to add a result to text. Maybe it will work and it will give some strange things for us. Yeah, it cannot. Okay, luckily it's not working. So if you try to add up a number with a string, of course, it's not working. I can imagine that if you multiply, no, in some programming language, if you multiply a string and a number, then you will get back the string in that many times that you multiply. But again, this is not working in R. Okay, so these are the simple variable types. You will use these variables a lot. This kind of variable association, when you just give a number or a value to a variable, is very common in the beginning of your scripts when you define your constants. So for example, if you run a script which is filtering a FASTQ file and keeping only next generation sequencing reads that are better than a threshold in quality, then you can say that, okay, my threshold is 25 or 30 or 33 in your very beginning of your script. Because if you want to change this, you just have to change that one number there. It's even better if you don't write your constants in your scripts, but this is not the subject or the topic today. We will speak about this later, how you can use parameters later to define these kind of constants in your scripts. But as I said, it's very common that you are using this kind of very simple variable associations as well. But it's much more common that you do something that you are reading in a file, taking out two things, and you are just, for example, looking for the sum of the two numbers, or you are looking for the length of your sequence. If you read in a FASTA file and you read in the sequence itself, many times you want to know how long is the sequence. So of course, I think there's a length command, but again, this is not the topic of today. If we are looking for the length of our text variable, which should be a long sequence, it's just hello at the moment. Okay, length is for a different purpose in R. It's for giving us the number of values in a vector. I think, yeah, it's not for string. Okay, I will find out later. But there is, I'm sure there is a string length comment somewhere in R as well. But anyway, these are the simple variable types. So again, if we want to comment what we did, then we have the simple variable types in R. The first one is a numeric type variable. Both of these, you are just storing the number in different ways. The second one is, which is called character type variable. In bioinformatics, you will use character type a lot. Refresh result. Is it a question for me from Hannah, or I'm not sure. Okay, there's a chat window something, and I will just, okay. Put this here. And the last type is you can also use T and F. I think it's also working. If I just say F, then the Boolean var will be logical as well. Yes, so it's F. There is one thing which I don't really know how R behaves. Let's say that our maximum value is 300, but between parentheses. So as you see, I'm trying to force R to handle this number as a string or in R as a character type variable. So I hit Command Enter and we check what is Maxwell. Then it's a character type variable. Let's try to add the max value down here, or we can actually try it here to our result. And again, it's not possible because they are different types. But we know that there is a number. The reason why I highlight this, because as soon as you will do programming, you will read in a lot of tabular data. A very simple BLAST output contains numbers, but if you read it in as a string, you cannot handle it as a number. But luckily, there is a command, which is, I think, the as numeric. So what we do, we actually convert max value from string to numeric. And here it's working, it's 303 down here in the console because it's now 300. Of course, I don't think it will work with the text variable. Let's try. Which is not really a number. Well, my guess is that it will be converted to 5 because it has 5 characters, or it will be converted to 1 because it's not empty, or it won't be converted. Let's see what is happening. No, it doesn't like it because it doesn't really recognize the number. So let me just read it from here. Okay, so this is how you can convert to one type to the other. And it's also true that we can use the value of minimal value. It's not there. We can use the value of the result here. If we want to print something, if you want to put two strings together in R, you have to use the paste command. So what I'm do is I will put here text and I will put here result. And I can imagine that it will work. Yes, it's working. But in this case, the conversion happened when I ran this line. So the result, which was a numeric variable, was converted to a string and was put together with hello and used by using a space as a separator. Space is the default separator for paste, but you can say sep equals to a dash, and then the separator between the two strings will be a dash. And if you put in more than two strings, so for example, you are putting back the text again, which is completely valid again, then you will have hello, free, hello. So you used the variable called text 2 times. This is again something what you will use a lot in bioinformatics, because you are working with a lot of input data, and usually you want to do some kind of output as well. Most common things what you will do, you know, it's just now a dummy line, but you will, of course, probably will have an ID, a variable that is containing the ID of your sequence. Then you will have a sequence length. You will have like a GC content variable containing the GC content of your sequence, and you will have like a source organism variable. Okay, and you want to put this into your final table, which will be a tab separated table. Then you will give the sep equals to \t, because this is how you can define a tab in programming languages, \t. Of course, I cannot run this because I don't have the ID variable, I don't have the sequence length variable, I don't have the GC content variable. This is just an example how you will output your results when you will do your bioinformatics script, or we will do it together. So let me just comment this out, because I cannot really work with this at the moment. Okay, so we went through the basic variable, the most basic variable type, which is the variable which contains one thing in it. Is there any questions now, or should we, or any things what is not clear, or we can, if not, then we can jump to the next variable type. Okay, if there's no question, then we will go to the next level, which is called in R the vector type variable. Again, this is how R calls it. In other languages, it can be a list or a dictionary or library or any other things. It's not always the same, but for the vector variable, the most important thing is, especially in R, first of all, it only has one dimension, so it will contain multiple values inside, but only in one dimension. So if you think about an Excel table, this is like one row or one column, but not the whole Excel table. So in vector, you can only store something in 1D. And very importantly, in R, you can always have exactly the same types in vector. So if you cannot put in a number and a character type. You can put in many different strings, or you can put in many different numbers, but you cannot mix them. If you try to mix them, they will be converted, and you will see how. So, how we can create vectors, or how do they look like? The easiest way to visualize is to make a series of numbers, which is very simple in R and many other programming languages as well. So if you want to get numbers from 3 to 8, it's just simply 3 colon 8. If you hit enter, you will see down here that it's 3, 4, 5, 6, 7, and 8. Of course, it's not in a variable yet. So let's just put this into our number list variable exactly the same way as we did before. We are using this left arrow. And now we have the number list here. And I think if we click on it, no, we cannot click on, we only can click on data frames. But as you can see, it's a list of integers. So it's now, very importantly, it's an integer. And it has 6 elements. And the reason why you have this 1:6 here is that these are the indices for each element of the vector, which is very, very important. If you want to take the third element from your list, you just simply say here, number list, and in square brackets 3, command enter. And as you can see here down here, it's 5, which is really the third element of your vector. We have to put here a very important comment, or starts counting vectors with index 1. This is less common in programming languages. More common is that they are starting counting at 0, just to confuse you, just to confuse everyone. So if you are looking for the first element of your number list, you have to say number list 0. In R, you have to say number list 1. That will be the first. This is much better for those people who start learning programming, because this is how you would think. The first element should have the index 1, because that's the first, that's 1. But in other programming languages, this is different. In many other programming languages. So that's why the third one is there. Let's try to put in. Okay, let's try a different way of list creation. Let's have our fruits variable. Here you will use this C. C is again a built-in small function in R, how you can create vectors, and you just list those things which you want here, like banana, but no. Is the mango? Oh, yeah, mango. That's good. Just to have non-UK fruits here, non-European fruits. If I say enter, then again we have our new variable called fruits, which is a vector, has 3 elements. So the indices are from 1 to 3, 1, 2, and 3, and this is the content. If I try and change the apricot to 300, and this is what I said, that R is very strict. If you are defining vectors, you can only have the same type in it. It will create, but as you see here, it's not a number anymore. It's a character type. Variable. If I say fruits 2 here, which will be the 300, it is 300 down there. But if I try to add our result variable, which was 3, it will give us the same kind of error message again, because even if it looks like 300, it's not 300. It's a string, a character type variable containing the word 300, letters 300. Of course, we can use the as numeric transformation, but very importantly, even if I don't put in parentheses here, or quotes, sorry, if I don't use put quotes, the 300 here, I put it here as a number, it was converted to a string by R, because it can only put the same type of variables into a vector. So this is not working. And as we saw before, we have the logical variables, so we can have the answers variable and put in, again, using this C, false, and true. It will be a logical vector containing just logical variables. Again, if I put here, if I just simply put this into quotes, double quotes, I think it will change the whole thing to character vectors, because R tries to store all your variables, and it cannot transform the string logical, but it can transform the logical to string. So that's why it will transform everything to string. Everything can be transformed to string, even a number. Okay. So let's just put it back, because we want a logical vector here. And I think, so we have now a vector with logical values, we have a vector with character values, and we have a vector with integers. And I think here, if we make another number list with decimals, and say we have 0.12 and 0.23 and 0.45, then it will have a different type. So this one is containing integers, and this one is containing numeric values, which are actually decimals. Interestingly, they have, it seems that they have this same size, but I don't think in reality, in memory, they are occupying the same amount of memory. It's much, you need much less memory to store integers than decimal numbers. Of course, you can add up these two different types, because they are all numeric types. So if I want to add my number list 2, so the second element of my number list, which will be 4, that's the second element of my number list. If I'm adding it to my number list decimal, you can always use the autocomplete by going on that variable name you want and just push tab. It will autocomplete. It's also good for preventing you from mistyping. And I will use the third element of this one. And it will add up nicely. So it's 4 plus 0.45. I think R can give you a bit of laziness, and you can just do this. In many programming languages, this is working. Yes, it's the same. So you can just omit 0 if your number is between 0 and 1. You don't have to write the 0 there. But actually, I like to write there. I like a bit more having the numbers in its forms. Why do you need vectors? In many cases, you will put your sequence IDs into the list. You will put your sequences in a different list, you will put your calculated sequence length into a list, and then or vector, and you will work on this vector with the R. For example, you want to calculate the average length of your sequences, or you want to calculate the average GC content of your different sequences. So you will put each individual GC content into your variable, and then with one simple command you will calculate the average at the end. You can also change the values in your vectors. Okay, so this is, you can put your comments before or after. As you see here, I put a comment after my command. I can put it here that this is how define a vector containing numbers from 3 to 8. This will be a vector of type variables. And this is a vector of logical type variables. It's perfectly okay if you forget most of the things what we are discussing today. It will come back, but when it will come back and you don't understand something, you can just go back to this this meeting and refresh your knowledge on why did we use that special command and why that thing didn't work for me. So this will be a bit of like basics on how to use and how to define variables. So what if I would like to change the third element in my number list, which is 5? Now I would like to make it 15. Then I can use the same kind of thing what we had here. Anytime you want to define a variable, this is what you will put in. This is always on the right hand side of your arrow, and it will go in to this one. Okay, so we can put here not the whole fruit or not the whole number list, but we can say, okay, I want to define number list 3. We already have a number list. We already have its third element, but we will just simply write it to 15. And as you can see here in the environment tab, now we have 3, 4, 15, 6, 7, 8. I think, but I'm not sure, we can also, so this is how we can redefine an element in a vector. What if we want to put in a brand new value into the vector? But let's say that I would like to put in an element, but not the 7th position. Yeah, of course, the 7th position would be the next one. So we have 6 elements, 6 things in our number list vector. What if I want to define the 10th element? Number list 10. Let's make it 120. So as you see, there shouldn't be any gaps in vectors. So what happened is that the 120 went to the 10th element of the list, but the 7th, the 8th, and the 9th element was treated as well, but without any value. So the NA is, of course, the not assigned or not available. So there is nothing. It's actually just a gap, a hole. But the indices are defined, which is very important because from now, the number list is a 10 element long vector, even if we only have 6 plus 1, so 7 values in it. And of course, as I told you before, you can do a lot of things, and just show you one thing here. But this is again the topic of our next meeting. So if you, for example, want to calculate the average of this list, I hope there is a mean. The problem is that we have those NAs there. So the mean is generic function to calculate the arithmetic mean. But if there's an NA, it doesn't like it. But luckily, we have this NA.rm parameter, what we can use, which is in default, it's false. So it doesn't remove those elements in the vector, which has a value of NA. And that's why it is giving us this strange result. But if we say NA.rm true, so just remove those elements, then it will remove these 3 and calculate the average of the remaining numbers. So it's a much better number now. Can you add a new value within the number list, but not overwrite any of the previous numbers with the vector? So what you will do quite a lot of times is that even if you don't really want to follow the indices, so the easiest way, if we now give a value with an index 11 to a number list, so we can always say number list 11, and it will be 45. Sorry, I should do it here. But now, as you see, yeah, it's now a bit longer than what we can see. But it is there as an 11th element. If you just say simply number list here, then you will see the content of the variable. But you don't always know what's the next index. And I think there is a command called push, but I'm not sure. There is a command push in many programming languages, not in R. Let me just make a very fast check. There is a push function, but it's not in the main package of R. Okay. Okay, so our number list has 11 elements at the moment, and now we can use that command I wasn't able to use to give you the length of the string. So if I say length number list, it will give us 11. Okay, so this is actually the last index. So if we want to give, okay, I would put it, oh, not here, but here. So our task is put a new value into vector to the next index place. So what we have to do is we are having our number list. We have to put something here. I will tell you what, and we will give the 46 number. So what we have to put here is, in our case, it's 12, but we don't know if it's 12 or if it's 120 or if it's 1256. It depends on the size of our list. So the safest way to tell here that let's get the length of the list and just add 1. So we can actually put here length number list and +1. This is very simple. So this will be a number, which in our case will be 12. So if I'm running this, then we don't see it anymore. Okay, let's go back to this one. And I'm now redefining number list. So number list went back to 3, 4, 5, 6, 7, and 8. And if I'm running this now, so our number list vector has 6 elements now. So this command will give back 6, +1 is 7. So 46 will be put in as the 7th element of the array, hopefully. And yes, it was. And if I run this again, then 46 will be put into the 8th place, and again, we put it into the 9th. So it will always be put in as the last element. Is this a good answer to your question, Hannah? Thank you. Right, we are well over time, and we are nowhere at yet. Okay, the next thing, I won't go into the detail of matrices too much, because matrix is actually just simply a vector of vectors. So if you think about vectors, they are 1D objects. If you would like to make it as a 2-dimensional thing, like an Excel table or Excel worksheet, then you will have vectors in each place of your indexes. You have to define them a bit differently, and I will show you how. And sorry, but I will copy this because I very, very rarely do anything like this in R. Okay, I can't. Okay, so this is the next variable type, which is matrices or matrix type variable. Let's call it M. And yeah, we just have to say matrix and row equals to 2 and col equals to 3. So this one is in a bit different section here. We can also click on it now. It will come up here, right next to our R script. So we have a 2-row, 3-column table without any values. Matrix has the same rule as vectors. You can only have one type of thing in your matrix. And you can define, I think, but again, I'm not you can define values like this. So if you say that m1, 2, which means that it is the first row, second column. So row number, column number, which will be 3, or 2, 1, just to be very creative, will be 6. Then you can see that our m variable now has 2 different numbers in 2 different places now. And you can also take the values out of your matrix like this. In bioinformatics, you are using matrices, for example, if you want to do, if you have a distance matrix between a lot of different bacterial isolates and you calculated distances based on something, and you have a lot of numbers in your matrix. That is usually a symmetric matrix, but it doesn't have to be symmetric. This is not a symmetric matrix, for example. It has more columns than rows. Again, I think matrix will come out or will come up much less than vectors and the next variable type, but as soon as it will come up, we will just repeat these things and we'll remember what is a matrix. I think you cannot really assign a value to a matrix which hasn't got the place. So if I say 4, 6, which is of course out of the dimensions of the matrix, yeah, it's not working because it's out of bounds. So the matrix has to be defined. The matrix size has to be defined. It's not the same as the vector. As you saw before, if I'm defining a vector with 6 elements, I can add the 7th, 8th, and 9th elements anytime. This is not working for a matrix. For a matrix, you have to define the size and then you have to work within that matrix, which is actually okay. I can imagine that there are commands how you can add rows or columns, but this is not the topic for today. So I will just put here a comment. I will put up everything. I think all these R script works as well to the Google Drive. So this is not working because it is out the matrix. I hope it is clear that we don't have a 4th row and 6th column because we only have 2 rows and 3 columns in M. And there are 2 more variable types, which I think I will only touch the data frame because that's one of the most important variable type and one of which you will the most commonly work with. The reason why you will work with data frames and not matrices, because in data frames you can have different type of variables. So data frames and matrices from the first view look the same. They are both usually like a 2-dimensional table, like an Excel table. The difference is that in your matrix type variable, you can only have 1 variable type. In data frames, you can have as many as you want, but you have to have the same variable type in 1 column. So if you think about an Excel table, you have your headers in your Excel table in the first row. And of course, if you have something in that column, it will be always a number, or it will be always like a color if you have different docs, or if you have I don't know, different color bacteria. Then you have the color as a string or in as a character type. But in every rows you will have a string for that column. But the neighbor column can be a number. So that's why a data frame is much more versatile. And actually, most of the times when you import data into R, you will import it to a data frame. So again, let me just create a data frame. So this could be the frame type variable. Usually we are just say df, like data frame. And here I have to give the first column, which will be like color. I hope it will work because color can have meaning as well in R. It will be a vector of red, green, and no, it should be black, not blue. Let's put in some fantasy. And the next column will be, let's say, speed. So it can be a different car. The red car will be the fastest. Speed, which is again a vector of 100. So I have characters or strings here, and I will have numbers here, 100, 90, and 75. Let me do an error. Let me give 45 here, and I hope it will give me an error. It is. The reason is, as it says, arguments imply different number of rows. So what I'm doing now, if you think about an Excel table, this is column A with the header of color, and then red, green, black in rows 2, 3, and 4. And this is column B on the Excel sheet with the header of speed and with values in rows 2, 3, 4, and 5. The problem is that when you define a data frame, all columns has to have the same length. So it will work as soon as I delete it from here. And now we have the data frame. And if we open the data frame, you know, it somewhat looks like a matrix. So it has the values also in a tabular form, but instead of having indexes as column identifiers, we have our real column identifiers as color or speed. And the good thing is that we can always get this back. So I can always say that I would like to list my colors in my data frame. And this is a bit strange in syntax because it works with the $sign. So if I say this, it will give me back red, green, and black. The reason why this is not a string, so if you push this arrow button here, then you see that the type of the color is not character like this, but it's a vector. The reason why R is using vectors instead of strings is because if you have something that is repeating in your column, so let's say that we have 100 different cars in this table and 20 of them are black, then we only define black once as a vector. It will have a number, like it will be only always the 3. And instead of storing black, 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 so storing actually 5 characters for each cars, we are only storing a number, which requires much less space in memory, which is much easier to handle. And we know that number 3 will means black. Will mean black. Of course, the speed is stored as numbers. There is no point to convert numbers to vectors. Okay, again, most of the time you won't define data frames like this, but you will read in your tabular data with one of the built-in comments in R, which will put in the whole table into the data frame immediately. But many cases you will work with data frames and you will make your nice plots from the data in your data frames. And there is a very last type, which I don't really want to discuss in detail, which is the list type. Well, let me just try one more thing, if this is working. Yeah, so you can also pick individual elements from your this is listing all values in a column of the data frame. And this is showing one element in column. And the first one, of course. So the list type variable is actually a collection of anything. So in a list you can have, it's like a chest of drawers. And the first drawer is a vector, the second drawer is a matrix, the third one is a data frame, the fourth one is just a simple numeric variable. So it's not really easy to work with lists, and usually you won't create lists, but many times, especially complex functions in R, will create lists of many different things. For example, if you run a plot and you are not just looking for the actual plot, the graphical plot on the right hand side, but you want to see the numbers in the plot, or you want to see, for example, the function which defines a fitted curve, and you can usually find this kind of information in the output of the plot function. If you put it into a variable, it will be a long list of different things. There are examples, but if you don't, I mean, let me just try to copy this from here. Maybe it will work now. Yeah. So the only reason why it's coded it's here that, so we have a list now, list of 4 different things. The first thing is just simply a numeric variable. The second thing is a character. The third one is a logical variable type, and the fourth one is as a complex number. So that's a good thing if you want to store many different things in one variable. But as I said, the most important ones are data frames, vectors, and the simple variables. This is what we will work the most during programming. Should we have a few minutes of break, and then go into the control, the for loops and if statements, or do you want me to continue now?
Can we just have a couple of minutes to go and get a drink? Is that all right?
Yeah. If you want like 2 minutes, then we can go into the basics of control structures, and then I think we won't have time today for going into the input-output, but that will be the topic of the next meeting then. Okay, I give you 2 minutes. Hannah, do you mean that it's not showing up here? They seem to run the script, okay?
Yeah, like you've got yours kind of appearing sort of as windows behind your script, and I don't seem to have anything appearing.
So you don't have them here, anything here, or you just don't?
Wait a minute. On the, I was kind of looking at the windows on the left-hand side, but actually.
Okay, so these ones here.
Yeah.
You have to click on them. If you click on in this part here, like where I have the 3 ops and 2 variables, then it will come up.
Oh yeah, awesome.
Okay.
Right, thank you. Perfect.
It also usually comes in. So if the most common way how you will meet with data frames is when you click on this import dataset button here. So here you can import from Excel, SPSS, but also from text-based data. And in default, when you import something here to R, it will be imported into a data frame and also automatically puts up the table here for you. So you can, if I close this and say here, it's already said before, if I say view F, or the F, which is the data frame, then it will come up there. So it's the same as I'm as clicking
okay.
here.
Yeah. Okay.
I have no idea what is happening if I click on this one. Oh, then it will give you this nice and detailed and very informative contents of the list. Yeah, it's you cannot change it, so it's not there for changing the values. It's not like in Excel. It's just for viewing. Or what you can do is you can order them by any of the values here, but you cannot change them. You can only change them by saying, okay, I want to change the first element of the color, which is red. Oh, actually, it's not red. It was red here. Yeah, it's red. So, like here, the dollar color 1, and then give it a value 2. And it will change. No. Okay. The reason why it is not working, because we have factors there, and blue is not a factor because our factors in the color column are black, green, and red. We don't have the blue there. So we first have to give a new value, a new factor value, and then we can use that. So I think if I say here 1, no, we can only say red. So we can only use those values which we have. But I'm pretty sure that we can give a new level. Okay, it's a bit more complicated, so I won't go into the details now, but we will. We will cover this next time.
Cool, thank you.
Ah. Mm-hmm. Okay, so this is how you can print in my bottom left corner, how you can print out how many levels do you have, how many different factor levels do you have in your column. And you can actually define it like this. So if I'm saying C, just copy it from here. But also adding blue as a level. Now we have 4 levels. So now I can change this first one to blue. And it's working. And it's now blue, this car, just because we changed the colors that can be added. This is also very good for avoiding, for example, mistypes, or you know, there are so many tables where you have something with like the capital as the first letter, or without capitals, or written a bit differently. So with factors, you can avoid these kind of redundancies in tables. Okay, everyone is here and back. Rhiannon?
Yeah, hello, sorry.
I think the only thing what I will cover today is the for loop, especially because we have the vectors here, and because the for loop is one of the most important things you have to know if you do programming. I know that in that video I sent you, the long video, they started R is a very powerful language because you don't have to use for loops, but but actually I think it's very, very useful to learn how to use for and while loops and what can you use it for. So there will be a new section here for, I think it is called control structures in R. Yeah. A bit more organized. Okay, so we have our number list. Let's just put it back to a number list from 3 to 8. And we can say, and I have to check it. It is the most simple for loop we can do. If we run this, so as is so, okay, now we have to say print. Ah, okay. So what did we do? First of all, the for loop creates a new micro script in your script. Everything that is happening under the hood of the for loop is between these curly brackets. And what is happening is that the for loop is going through the number list and put in the values of that vector into the variable I, but in every cycle, it will be put in only one element will be taken out from the vector. So in the first cycle, the first element, in the second element, and so on. So this is why the 3 was printed out and then 4 was printed out. If we say here, print hello, and run again, and I'm now highlighting the whole for loop and pushing Command Enter, then as you can see, within the for cycle, first the I was printed, which is 3 in the first cycle, and then the hello was printed. And then the for loop went back to the beginning, and the I got the second element of number list, printed it, and print hello. And this is how it went through. It's even better if I'm saying that I want to multiply I by 2. So now the first element, which was 3, will be printed out as 6 because it's 3 times 2, 4 times 2, 5 times 2, 6 times 2, and so on. So in the most simple for loop, or the most simple for loop you will use to go through all the elements of a list. This is very common. You are reading in sequences and you want to check them for something. You are reading in BLAST outputs and you want to check the identity of these, and you only want to export, or you want to work forward with those which are over a certain threshold. Okay, and this is how you go through a list. So you read in that list into a vector, and then you will go through the vector. There are different syntaxes for for. This is the simplest one. There's another one when you want to go along by indexes. And then you have to do this. There is a curly bracket. Yeah, it always makes you an automatic close for the curly bracket. Let's just first run this. If I copied this thing here, paste it here, and just run this line, and what you see is it creates a new vector with 1, 2, 3, 4, 5, and 6. So actually this function, the seqalong, is creating you a vector from the indices. So these are the indices within our vector. There is a value with index 1, which is 3. There is a value with index 2, which is 4, and so on. So if I'm printing I here, execute, then we will get back these numbers. We don't really want to get back these numbers. If we want to print out the real content of my number list, and we have to put the I into square brackets, because this is how we can take out an element from a vector. So if we run this, then we are getting back the real values of my vector. So it is actually the same as this kind of thing, but there's a big difference here. The difference is that we know which one was which was the index. And if you think about a data frame, so let's say that we have a data frame and we want to find that car, the color of the car, which has a maximum speed of 90, then we are going through this. We are going through the speed column, and we find that, okay, this is the second element. And then we can just take out the second element from the color variable. Let's do this, because then you will see. So, but for this, we will also have an if statement. So we will have the control, the very important control structure. So what we are doing, let's start with the same thing like this, just copy and paste, and we will rewrite. So we are not going along the number list, but we are going along the df dollar speed. df dollar speed. So if I'm running this, then I will get back the 100, the 90, and 75. So now what I'm doing is actually the same as you would parse a BLAST output. You are running BLAST with your protein or gene, and you will get back thousands of hits, but you're only interested in those ones which are has an at least like 95% of identity level and covering at least half of your gene, because you are looking for example, antimicrobial resistance genes. And you don't want those hits which are only covering like 30, 40 base pairs, but you want the size of your, at least half size of your reference gene. Then you will go through two different columns, checking the identity, checking the length of your alignment, but what you are interested in is not those numbers, but the ID, which is in a third column, somewhere in the beginning, usually on your BLAST output table. So instead of just printing out, let's define a new variable here as a target speed, which will be 90. It's very important to hit Command Enter here, so it will be in our environment. And we are using the if, and if is exactly the same as you would do it in real life. If my value is equal to something else, I will do something, okay? If my df speed I, because we are now checking all the elements, so the first, the second, and the third element will be checked as well. You have to use double equal. I will tell you why soon. If it is equal to target speed, then I'll just simply print out the speed. I thought it would be moved. You don't have to use indentation, so you don't have to use these two spaces here, but if you use it, it will make your script much easier to read, because you know, which block starts where and what is inside which block. So again, the if has its things within its own curly bracket block. So this print out will only happen if our current speed, what we are checking, is equal to the target speed. Let's just run first, and then I will explain why did we use the double equal sign. And we only print out 90. So we don't print out all the speeds. We only print out that speed which is equal to our target speed. But we were not interested in the speed, but we were interested in the color. So we only have to rewrite this to color. So we are checking the speed against our target, but we are printing out the color of that car. And it will be green. It's not important what levels are here. This is actually the result. This is what we have here. So the reason why we have to use the double equal sign is because we are checking something if it's equal or not. The problem with the single equal sign that it can be used to assign variables the same way how we use the arrow. So I can say target speed equals to 100. It is the same. So our target speed now 100. It's a bit silly, but this is how every other programming language defines variables, and this is how R and I think MATLAB is defining variables, but R can use both. If you do this, this will always give you back, this will always be true because you are assigning a value to a variable. I have 10 minutes left. But in an if statement, you want to check if something is true or false. Okay, so we are going through all the speed values in our data frame. In the first cycle, first 4 cycle, this thing here will be 100 because that's the first element of our speed column. It checks if 100 is equal or not to my target speed, which is, I won't delete, I just commented. So it will check if that 100, which is now here, equals to 90 or not. And because of the double equal sign, if it's not equal, it will give back a logical false. And if we have false here, then the things within the curly brackets will not be executed. If we have a true here, it will be executed. I don't know if R knows the triple equal sign. I'm not sure. I will check it for the next meeting, but there is even a triple. You can use even this one. I don't know if we can just simply use it now. I think it doesn't like it. Okay, there is no triple equal sign in R then, but in many programming languages, you have a triple equal sign, which also checks the type of the variables. So if you have 2 versus 2.000, then okay, I will just write it like this. So this will be true. 2 triple equal sign 2.000. This will be false. Again, this is not in R, but there is a chance that you will do some other programming languages. This is an integer, and this is a decimal number. Even if it's the same value, this is a different type in many programming languages. So they won't be equal. Okay. Let me just delete it from here because it's not R. Okay. I think I will stop here, especially because it's almost 5 p.m. already. If you have any questions, then we have 5 more minutes. But we will go through many more for loops in the future, I promise you. I will provide you some real data for the next time, and we will go through that real data, and you will see the for loops and if statements in action. We will use these a lot. So if it's not clear for the very first time for you how and why to use the for loops, it's okay, because we will use them a lot in the future and you will understand them. Is there any question?
Could you just explain seek along, what that means?
Yeah, so seek along is a function, it's a built-in function. So if you anytime you are I'm writing something and it's strange, you can also use the RStudio.
Okay.
I'm just putting the chat group over and over, and you can just seek along, and it will describe you that it actually gives you back a sequence of numbers. And if you are giving your vector as the parameter of seek along, so okay, let me show you here down in the bottom left corner how you can make a vector from 14 to 17, okay? This is 14, 15, 16, 17. If I'm putting this into seek along, the same kind of 14 to 17, it will give you 1, 2, 3, 4. So it will give you the indexes or indices of this vector. The first element is 14, second element is 15. So this is only, I mean, exactly the same thing what we have here can be done in many different ways. Exactly the same if I say for e in